some example problems from section 1.4. So to start with, in these exercises, so this exercise, use the graph of f to sketch each graph. So here's the function, which is this function here, and so then what we're going to need to do is graph each of these. Now to do this, I have cunningly created some copies of said graph, so I can just kind of sketch what is going on beneath it. Now it is sketch, so here's how you might do that. F of x minus 1 would mean that the graph has been shifted down 1. So that's what f of x minus 1 would be, just so we're clear what we're looking at. Which means each of these points would be shifted down 1. And you could identify these, and all that would happen, the shape would not change. It would simply drop each of those points. So -2, 3, 0, 2, and 1, -1, and of course this point would be 3, -2. Gets a little bit cluttered, but all it does is shift the graph down 1. Alright, for the next one, which is B, we're doing f of x plus 2, and remember this, because we're affecting the independent variable first, has the opposite effect. Instead of up or down, where it works like you expect, positive or negative, this is actually going to shift it this way. That's called left 2 units. So that's what that means. So I'm going to take another one of my little graphs down here, and I'm going to sketch this thing so it's 2 units to the left. So what I'm going to do is I'm going to take each of my cardinal points. I'm going to stop identifying them, but if you think about this carefully, 1, 2 units there would mean that that's at -4, 4, because it wouldn't go up or down. This would go 2 units this way, this would go 2 units this way, this would go 2 units this way, and then we can connect them to get our graph. So if you can move the cardinal points, that's supposed to be a straight line, believe it or not, that'll get what you're looking for. Okay? All right, for the next one, f of x minus 1. So C is f of x, now it's f of the quantity x minus 1, which means that we're moving right 1. So back to the well. I'm going to grab another one of our graphs. We're going to take it and we're going to shift it 1 unit that away. So what we're going to do is we're going to take this point and we're going to take this point and shift it one this way, take this one this way, one this way, and then this one this way. Please note, when I'm shifting horizontally, it's not, I repeat, not shifting it vertically at all. It's just shifting all the points 1 unit that way. D, D has a couple of things going on. But D is going to be a bit more complicated. So opposite f of x minus 2. So let's write this down. Opposites f of x, then minus 2. Now, order of operations are kind of important here, so let's be careful. Opposite f of x minus 2. So you can see my little cache of graphs here. Opposite f of x minus 2. So what's going to happen first from an order of operations standpoint is the negative, which means it's going to reflect over the x-axis first. Then, so this is outside, it's going to go down 2. So here's where you're going to have to bear with me. So as I'm doing this, it means that I'm going to reflect over the x-axis first. That's going to be thing 1. Now the nice thing is when I reflect, let's start here. Reflecting over the x-axis means that this is going to be 4 away, so it's going to be, oops, let's get rid of that, that'll get messy. Down here, as a matter of fact, it's going to be at -2, -4. This point is going to be down here or thereabouts, at 0, -3. Reflecting over the x-axis, just change the sign of the y. This point's actually going to stay in the same spot because it's on the x-axis. And then this point is going to shift up here to 3, +1. However, we're going to take all these points and then we're going to have to shift them down 2. Now, I have this capability, you may not. I'm then going to shift this down 2 units, which means that all these points get shifted down 2 units, which means in the end, what happens is, I'll look for the eraser, I'll find the eraser. They're going to end up being 2 units lower than after the reflection. So what that means in the end is, this will be at 3, -1. This will start it here, went down, so it's going to be at 1, -2. This is going to be at 0, -5, and this will be at -2, -6. Okay? It's kind of important to get the sequence correct. Almost there. E, f of opposite x, is not actually that hard. So E, which is f of opposite x. So when we affect this directly, this ends up being a reflection over the y axis. So we can take our sample graph here. Let's move this down here. We take our sample graph, and to reflect it over the y-axis, all we need to do is take each of these points and reflect it this way. Now if it's on the y-axis, it stays the same spot. So this will be at 2, 4. This will still be at 0, 3. This will go on the other side at -1, 0. This will go on the other side at -3, -1, so right there. And then we just connect them, and that is the graph of f of opposite x. 1/2 f of x. So it looks like I need to make one more copy of this. So just bear with me for a sec. There we go. So, 1/2 f of x. Okay. So, E is 1/2 f of x. Now this is where the fun really begins, because, there we go. This is a vertical stretch, but because it's 1/2, it's actually a vertical compression. Meaning we're going to take just the y values, and multiply them by 1/2. Meaning 1/2 of 4 is 2. It is not going to change in terms of the x. 1/2 of 3 is 1.5. 1/2 of 0, well, once again, these compressions don't actually affect anything that is on the axis. And then 1/2 of 1 is -1/2, if you like fractions, is right there. So that would be a vertical compression. If you take a look, it's like we squish the grass closer towards the x-axis. And the last one, f, is, just make sure, f of 2x. f of 2x. F of 2x is a little bit trickier. So when we're talking about this, this is affecting horizontally what's going on, which means that this is actually going to end up being, now normally if this is greater than 2, we'd expect it to be a stretch if it was vertical, so it was like 2 times f of x. And because it's a 2 affecting this horizontally, it's actually going to be a horizontal compression of a factor of 2. What does that mean? It means that we're going to take this graph and we're going to squish it towards, well, what is 0, in this case the y-axis. How? By a factor of 2. So what we're going to really do is we're going to end up dividing by 2, and we're just going to be dividing, because we're just doing horizontal compression, we're going to be dividing the x values. So what that means is our new point would be here. This would not move because it's on the y-axis. That point, by the way, would be -1, 4. This would still be 0, 3. This would get compressed closer, and so that would be 1/2, 0, and then half of this would be graphically there, so -1.5, -1, and you can connect it, and it should look like, it's actually not on that line there, it's very close to it, right? This is a sketch after all, be merciful, and that would be it. Okay, library parent functions. Compare the graph of the function with the graph of its parent function. So this is y equals absolute value of x as its parent function, which, as we know, looks like this. What's the difference here? This has been shifted left 5 units. How do I know? These work the opposite. So in reality, this will end up looking like this. So we would say it's been shifted right 5 units as compared to its parent function. All right, library parent functions. So identify the parent function So this looks cubic, so indeed it's going to be y equals x cubed, which by the way looks like that under normal circumstances, right? What's happened? Describe the transformations. It looks like it's been shifted up. And it looks like if we're going from 0 up to here, that looks to be 1 based on 2, 3. Yep, it's been shifted up 1, right? So if you want to write it out more, it's been shifted up 1. But it also looks like it's been reflected. It looks like it's been flipped, specifically vertically. So we'd say it's reflected. And we want to say reflected, if you want to write it out, over the x-axis. We want to say which axis we're reflecting over. Okay? Now, rigid non-recurrent graph function with the graph of its parent. So its parent function is the square root of x. And because we're multiplying by 2, this would be a vertical stretch by a factor of 2. Factor 2, meaning we're multiplying everything by 2. So compared to the plain old square root of x, we would expect this thing to be stretched vertically, somewhat like that. Okay. Now, I've already gone ahead and done the legwork. Use the graphing utility to graph the three functions. So here they are. Here's f of x, and then g of x is opposite f of x, so this, and then f of 2x, which is this right here. So what we're doing is we're comparing these. What is opposite f of x? What has happened? That is a reflection over the x-axis. And if you compare these, green versus purple, it's been reflected. Now I did change the scale a little bit, but if you match the points, it is indeed just a reflection. F of 2x. So f of x compared to f of 2x would be what? Well, it looks like we've taken this thing and we have not changed it vertically because it's still going as high as 2 as low as -2, right? But we have compressed it compared to this, which means that this is a horizontal compression factor 2. Last but not least are these couple of problems. What's going on? Several things. So describe the sequence of transformations. So the parent function would be x squared. Describe the sequence of transformations. So what happens first? The first thing is inside the parentheses, so x plus 2 would happen, which is left 2. Then what would happen? We'd multiply by -1/4. So two things are kind of happening at once. Multiplying by 1/4 is a vertical. Now, because it's 1/4, there's actually vertical compression of factor 4 because we're taking and squishing it against the axis. And the negative, and these two, it doesn't matter which order you put them in. This definitely happens first. This could happen second or third, or you could flip it either way. Reflect over the x-axis. But last is definitely going to be the -2, which shifts it down to, as compared to x squared. In this last one, our parent function is y equals the square root of x. And of course, the first thing that happens is the shift of left 1, because that's inside the square root. Then we have another combination. So this time, let's do the reflection over the x-axis first, which is a negative, and the 3 is a vertical stretch factor 3. Like I said, these two, because you're multiplying by -3, you could flip-flop and it doesn't make a difference. But definitely the last thing would be to subtract the 6, which is causing it to go down 6. So those would be the transformations in that particular case. And that, I believe,